stoichiometry practice problems. Chlorine is used by textile manufacturers to bleach cloth. Excess chlorine is destroyed by its reaction with sodium thiosulfate. So we always need to balance our equation first. So 2, 1, 2, 2, 2. How many moles of sodium thiosulfate are needed to react with 0.12 moles of chlorine? So I'm going to start with what they gave me of chlorine. Then I'm going to look at my balanced chemical equation for the mole ratio. So for every 1 mole of chlorine I have 2 moles of sodium thiosulfate. 2S2O3. Whoops, moles. I forgot my moles. So this way my moles of chlorine cancel. I'm left with moles of sodium thiosulfate. There we go. And multiply across the top, divide by what's on the bottom, so you get 0.24 moles sodium thiosulfate. How many moles of HCl can form from 0.12 moles of chlorine? Start with what they gave you. They gave me 0.12 moles of chlorine. And then to go from moles of chlorine to moles of hydrochloric acid, I need to look at my balanced chemical equation for the mole ratio. So 1 mole chlorine will give, I need 2 moles of hydrochloric acid. So my moles of chlorine cancel, multiply across the top, divide by what's on the bottom, and you get 0.24 moles hydrochloric acid. How many moles of water are required for the reaction? Well, start with what they gave you. 2 moles of chlorine. And we want to go to moles of water. So for every 1 mole of chlorine, I have 2 moles of water. So my moles of chlorine cancel. Multiply across the top. I have that many moles of water. How many moles of water react if 0.24 moles of hydrochloric acid is formed? Okay, well I'm going to start with what they gave me. They gave me 0.24 moles hydrochloric acid. And for my balanced chemical equation, I know I've got 2 moles of hydrochloric acid for every 2 moles of water. Multiply across the top, divide by what's on the bottom, and I've got 0.24 moles of water. In dilute nitric acid, which is HNO3, copper metal dissolves according to the following equation. Well, first I always need to balance my chemical equation. So I've got 1, that's a 1, not a 7. 1, 4, 1, 2, and 2. How many grams of nitric acid are needed to dissolve 11.45 grams of copper? Well, I'm going to start with what they gave me. 5 grams of copper. And I want to know how many grams of nitric acid are needed. Well, first I need to get my grams of copper into moles. So I'm going to use molar mass. So I know there's 63.55 grams of copper in 1 mole of copper. So my grams of copper cancel. And then from my balanced equation, I know for every 1 mole of copper, I have 4 moles of nitric acid. So my moles of copper cancel. And now I need my molar mass. So every 1 mole of nitric acid, I have 63.08 grams of nitric acid. So my moles of nitric acid cancel. And I'm left with grams of nitric acid. Multiply across the top, divide by what's on the bottom, and you get 45.46 grams. Whoa, what happened? 45.46 grams of nitric acid. Okay, The reaction of powdered aluminum and iron to oxide. Well, I always need to balance my equation first. So I need 2 aluminum and 2 iron. Which reactant, if either, is the limiting reactant? All right, well, I need to figure out what they gave me first. I'm starting with 4.2 moles of aluminum. 4.2 moles of aluminum. And I want to go to grams of one of my products. And it says down here they want the mass of iron. So I'm going to go to grams of iron because that'll just save me some time. So for every 1 mole of aluminum, the molar mass is, oh, I don't need molar mass. What am I doing? I'm not thinking is what I'm doing. I already have moles of aluminum, so I don't need to go to grams of aluminum. I need to go from moles of aluminum to moles of iron. So for my chemical equation, I have 2 moles of aluminum and 2 moles of iron. So my moles of aluminum cancel. I want grams of iron, so for every 1 mole of iron, I have 55.85 grams. So my moles of iron cancel, multiply across the top, divide by what's on the bottom, and I get 234.57 grams of iron. So now I need to do it with my iron oxide. So I'm starting with 1.75 moles of iron oxide. And I know from my chemical equation, for every 1 mole of iron oxide, I have 2 moles of iron. So my moles of iron oxide cancel. And for every 1 mole of iron each, I have 55.85 grams. So my moles of iron cancel. Multiply across the top, divide by what's on the bottom, and I get 195.48 grams of iron. So I can only make this much. So this means iron oxide is my limiting reactant. Same thing. Calculate the mass of iron that can be formed from this mixture. Well, I already did that right here. Silver nitrate reacts with iron 3 chloride to give silver chloride and iron 3 nitrate. Alright, so we need to write these. Silver nitrate. So silver nitrate plus iron 3 chloride. This is my charge. It doesn't mean I have 3 of them. Got to crisscross to give silver chloride plus iron 3 nitrate. Crisscross. Alright, and then we've got to balance our equation. So 3, 1, 3, 1. A solution containing 18 grams of silver nitrate was mixed with a solution containing 32.4 grams of iron chloride. How many grams of silver chloride can be produced? Okay, so this is the product we want to know. This is what we're trying to make. So I'm going to use my silver nitrate first and see how much I can make, and then I'm going to use my other reactant and see how much I can make. So I need to go to moles. So my molar mass, I know in 1 mole of silver nitrate, I have 169.94 grams of silver nitrate. So my grams cancel. I have moles, and I know from my equation, for every 3 moles of silver nitrate, I have 3 moles of silver chloride. So that cancels, but I want grams. So for every 1 mole of silver chloride, I have 143.32 grams. Okay, so those cancel. multiply across the top, divide by what's on the bottom, and I get 15.18 grams of silver chloride. That's how much I can make with this. Now I gotta figure out how much I can make with my iron chloride. And they said I've got 32.4 grams of it. Iron chloride. I'm trying to go to grams of my product. So I need molar mass. So 1 mole of iron chloride is 162.2 grams of iron chloride. So my grams cancel. I'm left with moles. So then I go back to my equation. For every 1 mole of iron chloride, I've got 3 moles silver chloride. Okay. But I want grams, so 1 mole of silver chloride weighs 143.32 grams. That cancels. Multiply across the top, divide by what's on the bottom, and you get 85.89 grams AgCl. Okay, well, this is a lesser number. This is all I can make because my silver nitrate is limiting how much I can make. I don't have enough silver nitrate. So if I'm really trying to make silver chloride, I need to have a better equation or get some more silver nitrate. Alright, that's it for the practice problem.